What's going on, guys? In this video I'm going to be going over the sum and difference identities. So here are your sum of angles. So whenever you have sine of two angles added together, you can rewrite it as sine of that first angle times cosine of the second angle plus the cosine of the first angle times sine of the second angle. And then if you have cosine and then you have two angles being added, it would be cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. So that's for sum. Difference, they're kind of the same thing. The only difference is if you're subtracting, you are going to be subtracting for sine. Cosine, however, if you're subtracting, you are also going to be adding. Okay, so just make sure you're paying attention to um, which formula you are using. Okay, all right, let's look at some examples. So here I'm trying to look for sine of 105. So you need to come up with two angles that you know that add up to 105 degrees. So let's look at our unit circle. So I want two angles that I can add up to 105. So if I look here, 30 105 minus 30 would be 75, right? Yeah, and I don't have 75. So let's go to the next one. 105 minus 45 would be 60. So 60 plus 45 would be 105. So I can write sine of 105 as sine of 45 degrees plus 60 degrees, right? And then, so that means we are going to end up with, we're using sine of two angles being added. So sine of A, which is 45, times cosine of B, which is 60, plus cosine of A, which is 45, and sine of B, which is 60. And so what you're going to do here is you're going to actually evaluate these, right? Sine of 45, that is the y value, so square root of 2 over 2. Cosine of 60 is going to be 1/2, that is your x value, plus cosine of 45, that is square root of 2 over 2, and sine of 60, that is the y value, so that would be square root of 3 over 2. And then here we're just going to multiply together, square root of 2, and then on the top, square root of 2 times 1 is square root of 2, 2 times 2 is 4. Now square root of 2 times the square root of 3, square root of 2 times the square root of 3, whenever you do this, you can actually combine the insides by multiplying, and so this would be 6. So square root of 6 over 4, and so finally my answer would be square root of 2 plus the square root of 6 over 4. All right, go ahead and try number 2. All right, number 2. So cosine of 165. So if I subtract our first angle, which is 30 degrees, I would get 135. Let's check if that's an angle on our unit circle. It is, right? So 30 and 135. So that means I can write this as cosine of 30 degrees plus 135 degrees. So that we're looking here. So this would be cosine of 30 times cosine of 135 minus sine of 30 times sine of 135. And then now we can just substitute these values in. Now, cosine of 30 is square root of 3 over 2. Remember, cosine is x, sine is y. And then cosine of 135 would be my x value, which is negative square root of 2 over 2, minus sine of 30, it's my y value, which is 1/2, times sine of 135, which is positive square root of 2 over 2. Okay, so now I can do some evaluating. Square root of 3 times the negative square root of 2, that would give me negative square root of 6, and then 2 times 2 is 4, minus 1 times the square root of 2, that'd be square root of 2, 2 times 2 is 4, so this would be equal to negative square root of 6 minus the square root of 2 all over 4. Or you might also get something like negative square root of 2 minus negative square root of 6 over 4. These are both the same thing. All right, good. Now let's try number 3. So now if you notice, we have our radians. This is what we're used to whenever we're evaluating. So, and you notice that we have a denominator of 12. However, we don't have a denominator in 12 here. So we are going to have to figure out two angles that have a common denominator of 12. Okay, but what else is that these are going to have to um, reduce, right? So if I have something um, like 11 and 8, right? 11 plus 8, 11 pi plus 8 pi, that would give me 19 pi. However, 11 over 12 is not going to simplify, and that is not on the unit circle, right? So I need to figure out something that simplifies. So let's try, I always like to do 10 and whatever that other value is, so 9. So 10 pi over 12 plus 9 pi over 12. So here, 10 pi over 12, that can be simplified if I divide by 2. So that'd be 5 pi over 6. And then 9 pi over 12, if I divide by 3, 3, 6, 9, so that's 3 pi over 4. Right? So that means if we add 5 pi over 6 plus 3 pi over 4, we would end up with 19 pi over 12. So I can rewrite this as cosine of 5 pi over 6 plus 3 pi over 4. Okay, and so now we're going to use our formula of cosine A times cosine of B minus sine of A times sine of B. So cosine of 5 pi over 6 times cosine of 3 pi over 4 minus sine of 5 pi over 6 times sine of 3 pi over 4. Okay, so now this you should be able to do without the unit circle, right? You should have these, oh, great. You should have these memorized, right? So cosine of 5 pi over 6, that is negative square root of 3 over 2. Cosine of 3 pi over 4, that's negative root 2 over 2. Minus sine of 5 pi over 6, that is 1/2. And sine of 3 pi over 4, that is square root of 2 over 2. And then last little bit, negative square root of 3 times negative square root of 2. So negative times the negative is positive. That'd be square root of 6. And then 2 times 2 is 4. Minus 1 times the square root of 2 is just the square root of 2. And 2 times 2 is 4. So this simplifies to be square root of 6 minus the square root of 2 over 4. Okay. Now go ahead and try number 4. If you notice, it is negative. So we are more than likely going to have to use a difference angle. So we might have to subtract. All right, number 4. So I have negative 5 pi over 12. So again, I have something over 12, something pi over 12. All right, so negative 3, and then you do, or negative 3, negative 5, and you do want something to be able to reduce. So you either want multiples of 2, 3, or 4. Let's try 3 pi minus 8 pi, right? 3 minus 8 would give me negative 5. But then whenever I simplify these, 3 pi over 12 would simplify to pi over 4. And then 8 pi over 12, if I divide by 4, that'd be 2 pi over 3. So pi over 4 minus 2 pi over 3. So sine of negative 5 pi over 12 would be sine of pi over 4 minus 2 pi over 3. Now, if you didn't use these two angles, that's okay. I'm just keep following me as long as you to make sure you got the right answer. So this is going to be sine of pi over 4 times cosine of 2 pi over 3 minus cosine of pi over 4 times cosine, or no, not cosine, I'm sorry, times sine of b, which is 2 pi over 3. Now let's evaluate this. Sine of pi over 4, that's root 2 over 2. Cosine of 2 pi over 3 would be negative 1/2. Cosine of pi over 2 would be square root of 2 over 2. And then sine of 2 pi over 3 would be root 3 over 2. All right. Square root of 2 times negative 1 would be negative square root of 2. Then 2 times 2 is 4. Minus square root of 2 times square root of 3 would be square root of 6. And then 2 times 2 is 4. I have common denominator, so I can simplify my numerator, or combine my numerator, sorry. And this is the answer you should get. All right. So, and there's so many different angles you can use, combination of angles you can use. There is no right or wrong way. You should just end up with a right or wrong answer. Okay. All right, number 5. We're going to condense into a single trigonometric expression, then find the exact value. So these are pretty straightforward. If you look, I have cosine, cosine minus sine, sine. So cosine, cosine minus sine, sine. This is sine, cosine, that's not it. Cosine, cosine minus sine, sine. So we're using a sum of cosines, right? So that means this would be able to be simplified to cosine of 300 plus 15, which is really cosine of 315 degrees. And if you look on your unit circle, 315 would be, and we're looking at cosine, so that'd be positive square root of 2 over 2. All right, try number 6. All right, number 6. So I have sine, cosine minus cosine, sine. Sine, cosine minus cosine, sine. So we're using a difference of signs. So here, this would be sine of 13 pi over 10 minus 2 pi over 15, right? Well, we do want to find a common denominator so we can combine these. So I'm going to come off to the side and do that. 13 pi over 10 minus 2 pi over 15. So 10 and 15, that they're going to have 30 in common, right? 30. So I'm going to multiply this side by 3 over 3 and this side by 2 over 2. So 3 times 13 would be 39 pi over 30. And then 2 times 2 would be 4 pi. And then 15 times 2 would be 30. So 39 pi minus 4 pi would be 35 pi over 30. And then here I can divide by 5. So divide the top by 5, the bottom by 5. I would get 7 pi over 6. So we're looking for sine of 7 pi over 6, which would equal negative 1/2. All right, let's do the last two. We're going to look at the back. So it's the same thing, except now we have actual um, expressions and variables. So I have cosine, cosine plus sine, sine. So cosine, cosine plus sine, sine. That'd be a difference of cosines. So that'd be cosine of 2x minus 4x, which is equal to cosine of negative 2x. But you're also going to use your even and odd identities, right? Remember, cosine is an even function. So if you have cosine of negative x, that is equal to cosine of x. So we just get rid of the negative. So this simplifies to cosine of 2x. All right. And then for number 8, we have sine, cosine minus cosine, sine. So sine, cosine minus cosine, sine. That'd be a difference of signs. So sine of pi over 2 minus alpha. And if you notice this is one of our cofunction identities. So this is equal to cosine of alpha. All right, so that's all we're doing today. You do have a Delta Math assignment. Let me know if you have any questions.